Welcome to Mathematical Colors and Codes, Episode 2. I'm Sondy Eklund, and I'm a librarian at City of Fairfax Regional Library. Now, last time I showed you prime factorization and how you can show it using colors in a chart. Today, we're going to look at other ways to show prime factorization and how you can even use them to make colorful coded messages. Okay, let's start by making sure that you know what I'm talking about. Prime numbers are counting numbers that can only be factored as themselves times 1. So you can't multiply smaller numbers together to get these numbers. Composite numbers, you can multiply prime numbers together to get composite numbers. And every composite number, if you factor it down until you have only prime factors, that's called its prime factorization. Now, last time I showed you the first prime factorization sweater I ever made, where I showed with colors the prime factorization of every number from 2 to 100. Now, back in 2012, my blog post I'd written about that sweater went viral. So I decided, well, why don't I make a different prime factorization sweater showing prime factorization in a different way? This time, instead of colors in a grid, I'd use stripes across a cardigan. Now, to try out my ideas, first I made a scarf. So let me show you how those work. First, let's look at the scarf. I decided to use stripes instead of a grid to show it, but it's the same idea. Each prime number gets a color. This time, instead of using white as the background color, I used black as the background color. So black is 1. So we've got a stripe for 1, then a stripe for 2 is blue, then a stripe for 3 is pink, and I use black in between colors because this way any number might be fatter than any other depending on how many factors it has, so I have to have a way of telling when I'm done with a color. So here's 3 is pink, 4 is 2 times 2, so it's just twice as fat as the stripe for 2. Then 5 gets a new color, yellow. Then 6 is 2 times 3, so it's got blue and pink. Oh, and by the way, I used a reversible stitch so that the scarf will look the same on both sides, but that's why it's not, it's a little fuzzy boundaries. Okay, then comes 7 is purple, 8 is 2 times 2 times 2, so it's 3 times as fat. 9 is 3 times 3, 10 is 2 times 5, 11 gets a new color, 12 is 2 times 2 times 3, 13 gets a new color, 14 is 2 times 7, and it goes all the way up to 50, which is 2 times 5 times 5. So one thing I love about the scarf is that it turned out really pretty, even if you have no idea that it's mathematical. If you do know it's mathematical, you have the same things as in the sweater where you can go 1, 2, blue, 1, 2, blue, 1, 2, blue, 1, 2, blue, all the way to the end. And you can go 1, 2, 3, pink, 1, 2, 3, pink, 1, 2, 3, pink, 1, 2, 3, pink, and 1, 2, 3, 4, 5, yellow, 1, 2, 3, 4, 5, yellow, and so on. So the patterns are all there, but you see them in different ways in the scarf. Now, a thing about the scarf is I got up to 50, but it's super long. So I decided I didn't want to do the cardigan that way because I wouldn't get to a very big number if I made every number fatter if it had more factors. Okay, here's the prime factorization cardigan. I used the exact same colors as in the scarf, but in order to make it not super fat, I decided to put all the factors in one row. So if you look at the row for 6, I've got 2 and 3 all in the same row. So I did a stitch of 2, a stitch of 3, a stitch of 2, a stitch of 3. And here with 10, we've got 2 and 5 in the same row. But then you'll ask, well, what about these where you have 2 rows of the same color? That's how I decided to do powers of a number. Because how was I going to make 4 look the same as 2? I couldn't just do a stitch of 2, a stitch of 2, because that looks exactly the same. So I decided if it's a power of a number, I'll give it another row. So here's 2, 3, then 2 times 2 is 4. Then yellow gets its own, or 5 gets its own. 6 is 2 times 3. 7 gets its own. 8 is 2 times 2 times 2. 9 is 3 times 3. And let me show you the other powers. Here's 16. That's 2 times 2 times 2 times 2. Here is 5 times 5. That's 25. Here's 3 times 3 times 3. That's 27. Here is 2 times 2 times 2 times 2 times 2. That's 32. And this one's really fun. This is kind of my favorite. It's 36, because 36 is 6 times 6. So I could have done blue, blue, red, red, because it's 2 times 2 times 3 times 3. But I thought it would be fun to show that it is a power of a number, but it's a power of 6. So I did 1 row of 2 and 3, and then another row of 2 and 3. Okay, then here we have 7 times 7, 49. And here we have 64, 2 times 2 times 2 times 2 times 2 times 2. And that's the last power in the sweater. It goes up to 78, which is 2 times 3 times 13. And I wasn't as able to control where it stopped as I was with this scarf. But I just enjoyed the way it turned out, and it shows that you can look at prime factorization in a completely different way. Same idea, but it looks completely different. Now, I promised you I was going to show you how to make coded messages with prime factorization. Here's the idea. If I can use colors to represent numbers, then I can also use colors to represent letters. Just assign the numbers 1 to 26 to the 26 letters. So A is 1, B is 2, C is 3, so on. And it's a very simple cipher, but what makes it interesting is if you then replace the numbers with colors based on prime factorization. So here's what the coloring sheet looks like for this week's episode. You've got a prime factorization chart exactly like the one last week, except this time I put 1 at the top because going A through Z from top to bottom, it makes a little more sense than starting at the bottom. But you would fill it out the same way. You're just going to 26. Now across the bottom, I put a shortcut to see what color is what number. Going to need 10 colors, and this time I want you to use a color for 1. Don't just skip it, because as with my scarf, we're going to use the color for 1 in between letters, because different letters use different amounts of colors, so you need some way to tell when one letter ends and another begins. So use a color for 1. You're going to just need 10 colors. So choose the 10 colors and then fill out your chart. And now let me show you how you can make a message. Like I said, we're going to put the color for 1 in between each letter. So here's a coded message that I use that method to write it. I use circles because that's easy to do on a computer, but you could use stripes, you could use squares, you could use rectangles, you can use whatever you want. But let me show you how you would decode it and what it's saying. Now, instead of putting the whole chart on this page, because that takes up too much room, I just put at the bottom what number each color represents. So now if you look at the start, I've got 4 red circles, so, and then a color for 1. So that's going to be 2 times 2 times 2 times 2 times 1. Then the next, and we'll multiply them all out after I've transcribed what numbers these all represent. Then the next color is 2 times 3 times 3 times 1. Then we've got 5 times 1. 2 times 2 times 5 times 1. 2 times 2 times 5 times 1 again. 5 times 5 times 1. Then you get, then we've got 2 times 2 times 2 times 2 times 1. Then just 1 by itself. Then 2 times 2 times 5 times 1. Then 2 times 2 times 5 times 1. 5 times 1. 2 times 3 times 3 times 1. 2 times 7 times 1, and 19 times 1. Okay, next step is multiply them out. So the first letter, you've got 2 times 2 is 4, times 2 is 8, times 2 is 16. Next letter, 2 times 3 is 6, times 3 is 18. 5 times 1 is 5. 2 times 2 is 4, times 5 is 20, and 20. Then 5 times 5 is 1. Sorry, 5 times 5 is 25. And so on. We've got 16, 1, 20, 20, 5, 18, 14, and 19. Okay, then we go back to the chart and figure out which letters those represent. So 16 is P, 18 is R, 5 is E, 20 is T, 25 is Y, 16 is P again, 1 is A, 20 is T again, 5 is E, 18 is R, 14 is N, and 19 is S. Okay, so our message was pretty patterns. Now, the first thing you'll notice is that it did take a lot of space to make a short message. I do promise that future codes are going to take up less space, but this one gives you the idea, and you can think about, well, how could I make it take up less space? If you think about, that was exactly the problem I had with my scarf. When I wanted to make the cardigan, I found a way to make it take up less space. Okay, but it is fun to maybe write a short message, and my favorite thing to show kids how to make is to write your name this way. So let me do an example with my own name. Okay, first step is you figure out which numbers are the letters of your name. So with my name, Sandra, I get S is 19, O is 15, N is 14, D is 4, R is 18, and A is 1. Next step is you figure out the prime factorization of each number. Or you could just use your chart where you filled it out. So either way. For my name, we've got 19 is prime, 15 is 3 times 5, 14 is 2 times 7, 4 is 2 times 2, 18 is 3 times 6, and that's 3 times 2 times 3. Now, I want to say with this one, usually I put the smallest number first, so I put it as 2 times 3 times 3, and you get the same thing. But one of the fun things about this code is you really can write the factors in any order you want. So if I wasn't afraid of confusing people with the example with pretty patterns, I could have done T as 252, 225 or 522. You can do it in any order, and I could have mixed it up, and that would have confused people, and they might not have realized it's all the same letter. But it doesn't matter. When you decode, when you multiply it out, you get the same answer. So you can do it in any way and throw off people who might be trying to decode your message. Okay, and then A, of course, is 1. So step is just take your prime colors and use the colors to write your name. Use the color for 1 to separate the letter. So here's my name and code. You can see I've got 191, 351, 271, 221, 3231, and then 1. So I've written my name in code, and you can do the same thing this week. You can download the coloring page, which has a prime factorization code chart, and then try writing your name. Think of other messages. Think of different ways you might do it. I use circles, but you can use squares. When I do this as an in-person program, I like to have foam stickers and use those, but you can use whatever you want. Think of ways to play with this, and we will go on from there in the next weeks. Thank you for watching Mathematical Colors and Codes Episode 2. Today you learn more about prime factorization and how to use it to make coded messages. Tune in next time to learn about non-decimal bases.